Next concept is to calculate the EOQ. The EOQ can be calculated using the formula. Okay, the formula can be used to calculate EOQ is square root 2 ds divided by h, and time between order of an EOQ equal EOQ divided by d. If EOQ time between order is reported in the monthly basis, you can adjust by multiplying it by 12 months per year. At EOQ, we can also calculate the total cost by using one formula, square root of 2ds times h. Okay, so we're gonna use that example to experiment on example 4. Okay, on example 4, is the same example that we use for example 2 and 3. The same example. So we're going to start up with, go back to example 3, 2 and 3. We're going to grab some section that are repeated over here, and then after that we are going to find out the EOQ by use square root 2 ds divided by h. 2 times d times s divided by h. Okay, you can find out that the EOQ is about 45.6, and once we find out, we can follow the same procedure that you find the rest of information. And but one thing to point out that about EOQ, that EOQ is the point when the ordering cost equivalent to holding cost. That's when you add these two costs together, you will get the total cost. You can also have another way to find total cost by using one formula. Remember that this formula can be used at EOQ point only. We can use square root of 2 times d times s times h 2dsh. Okay, you can see that two amount is the same amount. So you can choose either one approach to find total cost. Okay. Example 5 is another example that we can also use this formula to explore. Okay, this example, first we're gonna identify parameter. Okay, the demand per month is 400. We use small d to represent demand per month. If we have 12 months per year, demand per year will be 400 times 12, 4,800. Setup cost, ordering cost is 12.5. Holding cost is $0.12. Remember that H is dollar per unit per year. R is fractional charge per unit cost. So EOQ equals square root 2 times D is divided by H. Okay, so EOQ is 1000 square root 2 ds divided by H. Time between order equal EOQ divided by D. First unit come out as year. If we work 52 week per year, you can have time between order about 10.83 per week. Ordering cost equal, okay, just to review, ordering cost equal D divided by Q times S. Holding cost equal Q divided by 2 times H. I'm going to take D divided by Q times S, and also ordering cost equal Q divided by 2 times H. Okay, if your two amount is the same, you do it right. Okay, that's a good example. Now, in summary, EOQ point is the minimum point of the total cost. Is the lot size that guarantee the best lot size that guarantee the minimum total cost. Okay, and students also have many examples to explore. I hope you guys take advantage of the additional example that are shown on the slide. Okay. Now, next concept we are going to study is the effect of parameter on the EOQ decision. We call this sensitivity analysis. Okay, there are three main managerial insights that can be discussed. The first insight is the relationship between EOQ and the demand. The EOQ and demand has a positive relationship with each other. EOQ is related to square root of demand. Increase in the demand meaning the increase in OQ, which can imply that increase in the lot size is in proportion to the square root of the demand. The value of EOQ is also have a positive relationship with square root of the setup cost. When you load your setup cost, the amount of EOQ also can be decreased. The implication can be weeks of supply decreases. When the week of supply decreases, inventory turnover increases because the lot size decreases. The holding cost, on the other hand, has an inverse relationship with EOQ. Lower holding cost can encourage organization to increase the lot size. On the other hand, if the holding cost is large, the lot size can be decreased. Inventory system. Inventory system is a system that helps organization to organize or manage inventory. A simple inventory system can answer two questions. First, how much of the replenishment and when the replenishment should occur. There are two types of demand in inventory. The first type of demand we call independent demand. Independent demand is a demand that independent of other demand. Example of independent demand can be demand of finished good that's sold to end customer. Dependent demand, on the other hand, is a demand that dependent on other type of demand. The example of dependent demand can be a demand of raw material, part that can be used to produce finished good. Inventory control system can be used to manage inventory. There are two main system variables. The first system we call continuous review system or queue system. We can also call it reorder point system, ROP, or fixed order quantity system. We call it reorder point system because this system set up a reorder point at which the new order is placed. We call fixed order quantity system because this type of system order a fixed quantity every order. Therefore, in this system, quantity 1 or Q1 equal Q2 equal QT equal Qn. Continuous review system can be used to apply to any retail environment. Example, Walmart, Target, or Meijer. In this system, the inventory level is often checked every time customer link the item. Inventory level is always updated. This type of system is preferable for the independent demand item. To track this system, the system must know inventory position. Inventory position represents a level of inventory that's shown on the system. Inventory position may include many categories of inventory. The first part of inventory position is a physical inventory we call on hand. On hand is the amount that can be touched, rearranged, collect, and count. Another part of inventory we call schedule receive. Schedule receive is a logical inventory. It is the amount of inventory that not yet received. It can be inventory in transit, an open order, or an order in quarantine. Back order is the amount owed to customer. Inventory position is on hand plus schedule receipt minus back order. Look at this example. This is a cycle inventory model. The level of inventory starts out with a queue lot size. The queue is depleted as the time progresses. At some point, we call reorder point. When the inventory position reduces to reorder point, a new order is placed of a queue order. Therefore, in continuous review system, the highest point of inventory is always equal reorder points or plus queue. In this picture, it also represents a situation when the demand is constant. We know the demand is constant by looking at the slope, equivalent slope of the demand. When the demand is constant, the time between orders can be the same. Okay, this example shows the relationship between inventory position and reorder point. Inventory position equivalent to the amount of on hand plus schedule received minus back order, which is 210. If the reorder point is 100, inventory position when it is higher than reorder point, no new order is necessary. However, a new order will be placed at Q lot side when inventory position is less than or equal to reorder point. Reorder point can be calculated by using average demand during lead time plus safety stock. Average demand during lead time equivalent to average demand D small d times lead time L. This figure shows the importance of the importance of safety stock. This picture is a common view of inventory demand. In this common view, the demand is fluctuated with the wavy line. The demand rate can also be denoted by the slope of the demand line. In this picture, the first and second period, the demand rate can be quite high. The third period, the demand rate is quite slow. As you can see from this picture that if demand rate is not constant, the time between order can be different. Therefore, when the demand rate is not certain, time between order 1 not equal time between order 2, not equal time between order 3. On the other hand, the lead time and the quantity can be the same. To calculate the amount of safety stock, the company set up an appropriate service level. Okay, the service level or cycle service level represent the amount of customer service organization prefers to offer to customer. Now let me show you example. This picture show that the organization choose the cycle service level of a 95% or 85%. Cycle service level 85% means about 85% of time organization will have inventory to satisfy customer. About 15% of time the organization may stock out. With this picture you can also that on average the demand during lead time is about 50% of the amount of inventory. Okay, let's look at the handout. Handouts also, okay, it's a source of additional knowledge that are summarized from the book. Students are encouraged to review the handout. Okay, these also provide additional explanation about cycle service level. Cycle service level 90% mean about probability of 90% that the organization will have demand not exceeding the supply, or about 10% the organization will have a back order or stock out. Okay, with this notion we must turn cycle service level into a level of safety stock. To turn the cycle service level into a safety stock, we must calculate the amount of safety stock. Okay, the amount of safety stock equivalent to cycle service level Z value times standard deviation of lead time. Cycle service level is a conversion of the cycle service level into a standard deviation. Reorder point equivalent to demand during lead time times safety stock. Okay, so we're gonna experiment this on example number 6. On example 6, we start out by maybe identify a variable. First variable to identify is the unit cost 20. Okay, average annual demand of 1,000. And the the ordering cost is $5. Holding cost is $4. And lead time is 5 days. Okay, sigma lead time. Sigma lead time, okay, is 10 units. Average demand, okay, if organization have annual demand of 1,000, working 300 days per year, average demand can be 1,000 divided by 300 days per year. Okay, service level of 90% or 0.9. To convert service level into a standard deviation value, we are going to use the normal distribution. At the 90%, the z value equivalent to about 1.28. So we convert it to 1.28. Okay, now first thing first, we're gonna find EOQ. Okay, please review formula if you forget. It's QRT of 2 times D, okay, times S divided by H closed. Okay, number of order equal D divided by Q. Okay, 20 orders. Time between order equal EOQ divided by D. Of course, first unit always come out as year. And if we have 52 weeks per year, we can convert into about, hold on, not right, time 52, 2.6 weeks. If we have 300 days, let's convert into number of days, about 15 days. Demand during lead time is average demand times the lead time. Average demand is small d times the lead time is 10, about 8.33. Safety stock equivalent to Z times sigma L. Z times sigma lead time. Okay, so reorder point equivalent to average demand during lead time plus safety stock 71. Okay, inventory position. Okay, go back to the slide a little bit to explain it. Inventory position right after the reorder point is placed, the new order is placed equal R plus Q. So we're gonna be R plus Q. Okay, which is about 70 times D times L. Okay, I think I make a mistake over there. D times L. Okay, that makes a difference. D, okay, small d times L. Safety stock Z sigma L. Z sigma L. Okay, ordering cost equal D divided by Q times S holding cost equal Q divided by 2 times S. Of course, oh, might be wrong. Q divided by 2 times S times H, not times S, times H. Okay, how I know it's not right? These two amounts must be the same. Safety stock cost is the amount of safety stock you file times H. Total cost is the three costs added together. Okay, that's good example. You have all completed costs. Okay, that's a good example. Students also encouraged to review additional example from the slide to find out. Okay, next concept we're going to study about the relationship between sigma D and sigma L. Sigma D or sigma T we call individual standard deviation. Sigma L is lead time standard deviation. Okay, in this example, sigma T individual standard deviation for each week is about 15. If we have lead time over 3 weeks, you cannot add these three together become 45. That's not right. In order to find sigma standard deviation of lead time, we must convert sigma T into sigma of L by use sigma L equal sigma T square root lead time. Okay, let me show you the formula on the note. Sigma L equals sigma T times square root lead time. Real safety stock equals Z sigma L. Real point equal D times L plus Z sigma L. Okay, so with this example, we're going to explore on example 8. Okay, on example 8. Okay, and I leave example 7 for students to explore by themselves. Of course, the answer is at the bottom. On example 8, we have average demand or small d over 300, lead time of 9 weeks, and for each week it's 15 standard deviation. So if we have lead time 9 weeks, sigma L equal sigma T times square root L. Okay, and for the average demand during 9 weeks or lead time equal D times L. So the reorder point can be found after we find the safety stock. So if the service level is 0.99, a C value can be found by checking the normal distribution. 0.99 level is about 2.33. So safety stock equivalent to Z times sigma T, or we could just use Z sigma L if we already converted. Okay, so reorder point equal average demanding release time plus the safety stock. Okay, that's a good example. Okay, there are more examples on the slide that a student can explore. Students also have a chance to complete assignment to learn more. Okay. Next example is also a good example, which is example number 9. Okay, let's work on it. On example number 9, first we are going to maybe uh, identify variable. Okay, demand is 100 per day. Okay, and if we work 5 days a week, 52 weeks per year, so annual demand can be 100 times 5 days a week, 52 weeks per year. Okay, and also we have a parameter of sigma t of 30. We have lead time of 3 days. We have a service level of 0.92. Okay, at 0.92 we're gonna have to find out the z value. It's about 1.41. Okay, we have set of cost. Okay, sometimes I use A, sometimes I use S. A mean administrative cost. Reorder point also, sometimes I use R, sometimes I use small s. So setup cost is 35. H is 9.4. Okay, now your Q is square root 2 times D H divided by H. Okay, now safety stock, this case safety stock equivalent to Z times sigma T times, don't forget, square root lead time. Don't forget that if we have to find, we have to use sigma lead time. If you don't have sigma lead time, you have to use sigma t. You have to convert it. The other point equal average demand, which is D times the lead time L plus the safety stock. Okay, so if IP equal on hand 40 plus an open order for 40, there's no back order. In this example, you can see the reorder point is lower than the IP. So if IP is more than reorder point, a new order is not needed. Okay, we're gonna find total ordering cost equal D times S divided by Q. Ordering cost equal Q divided by 2 times H. Of course, the amount will be the same. Safety stock cost equal the safety stock times H. Total cost is the sum of these three. Okay, so these are another example of the Q system that we can explore. Okay, next we're gonna go back. Okay, students also encouraged to study more of example that available on the slide. Okay, next system we're gonna study we call periodic review system or P system. Okay, sometimes we call P system fixed interval system or periodic order system. we call fixed interval system because in this type of system the review period is the same amount. Okay, the type of system that can be used, for example of this, can be a vending machine when the inventory level review like once every week on every Monday or every month. Okay, the, in this system there are 4 assumptions. Original assumption can be used. First, no constraints are placed on the lot side. Holding cost and ordering cost the of interest. Independent demand can be used, and the lead time are certain. Okay, this picture show you a periodic review system. You might notice that P system is different from the Q system because the P system does not have a reorder point. Instead, P system have the T target inventory. Target inventory is the highest level of inventory in the system. The amount ordered in the P system is the different amount between the target inventory and the inventory position IP. So ordered equal T minus IP. In this system, you also can see that the length between order is P plus L. Okay, we can also call it production interval because at this in this period, organization is vulnerable of the demand. If the demand is peak during this period, there is no refill. Okay. This example shows the use of target inventory T and IP. If target inventory is 400 and inventory position is -5, we must order 405 of the new order. Okay, we will, okay, in order to find the target inventory T, we use average demand during the production interval, which is D times P plus L, plus safety stock for the production interval, which is Z sigma P plus L. Sigma P plus L equals sigma D or T times square root P plus L. P means reviewing period. Okay, with this example, we're gonna explore this example using example 10. Okay, on example 10, you can see that example 10 and example 9 is the same example. So we can start up which, okay, let me copy that. Okay, we can start up the same way by finding EOQ. Okay, but the P system may differ from the Q system because P system require P or time between order in a unit of the lead time. Okay, time between order in a unit of lead time is a reviewing period of P. Time between order equal D divided by Q, Q divided by D times, okay, if we work 5 days a week, 52 weeks per year, so P equal 4.41. I suggest that the P is not rounded. Safety stock equivalent to Z times sigma T times square root P plus L liter. Okay. Target inventory equal D times P plus L plus safety stock. Okay, if inventory position is 480, the order is the difference between target inventory and the inventory level. So the order amount will be 375. Okay, the ordering cost equal Q. Okay, hold on. Equal D divided by Q times S. Holding cost equal Q divided by 2 times H. Safety stock equal safety stock times H. Total cost will be the sum of these three. Okay, by the simple notion, if you compare between these two models, the safety stock cost of the P system is larger than the Q system, thus the total cost of the P system is higher than the Q system. Okay, now students also encouraged to study more example on the slide. Okay, now we learn about a little bit about P and Q system. Let's compare between the two. Okay, Q system is good because it's convenient, because we always know that the time reviewing period. So it is very convenient to schedule resources, transportation, or the material to shift or to produce. Also in the P system, if the reviewing period is the same period, sometimes the order can be combined to ship at the same time. And P system also does not need to review inventory often, only need to review IP when review is made. So the reviewing cost can be reduced. The bad side about P system is P system require higher safety stock, thus can increase the total cost of inventory. Q system, on the other hand, is preferable in situation when demand is high. When demand is high, more precise inventory system is needed. Inventory must be viewed frequently. Inventory system for the Q system also needs fixed lot size. Sometimes can also result in a quantity discount that you get from the supplier. Good thing about Q system also, Q system require lower safety stock, which may mean lower total cost. That finished the chapter 9 inventory management.